The most popular news of the past week has been that the Earth's core has stopped spinning and may even have started spinning in the opposite direction. In a single sentence, our rare press reported that the Earth's core is no longer spinning and may even be reversed. This news was presented as if it was a first or a very unusual event in the history of the world, and was shared by thousands of people with such a strange sense of humor and reality. Let's go beyond the noise and take a look at what is going on in the core beneath our feet. As you may have memorized in high school, our planet consists of roughly 3 layers: crust, mantle, and core. Depending on the purpose, it is possible to increase the number of layers, but these 3 are enough for now. The thinnest layer of our planet, the crust, really does wrap around our planet like the skin of a fruit, and thanks to the heat we lose to space, it can remain solid by supercooling. Even at its deepest point, this layer does not exceed 100 kilometers and is only 30 kilometers thick on average, and it contains all the land and oceans, and therefore us. As we go down into the lower layers, the temperature and pressure of our planet gradually increase, and the mantle layer, which is between 30 kilometers and 2,900 kilometers deep, is composed of molten rocks and magma due to this high temperature. For example, the lava that reaches the surface during volcanic activity comes from the upper layers of this mantle. The layer that matters for us today is the deepest core layer. We usually divide this layer into 2, the outer core and the inner core. The reason for this is quite interesting. Normally, as you get closer to the center of our planet, temperatures reach around 4,500 degrees Celsius. At this temperature, all of the material that makes our rocky planet rocky melts into a liquid state, which is why the outer core layer of our planet is liquid, as expected. As you go deeper into the core, the temperature rises even more, reaching 5,200 degrees. That's the same temperature as the surface of the sun. But despite this high temperature, the inner core is not liquid, but solid, just like the crust. The reason for this is the unimaginably high pressure experienced at this depth. The pressure is so high that despite the 5,200 degree temperature, the material, which is mostly composed of iron and nickel, elements that should already be liquid around 1,500 degrees Celsius, cannot remain liquid and become solid. It is this inner core layer that has been at the center of the news last week. The article was published in National Geoscience, a respected journal of earth sciences. In the article, a research team from Peking University announced that they had discovered that the inner core's rotation had stopped in the current years and may have started to reverse. The problem is that when you give the news just like that, it's perceived as if it's the first time or the only time, you know? You can get clicks with that. Yes, but you're not giving accurate information. That's what we call lying by omission. Yes, the article is about this stopping and starting to go back, right? So the people who put it in the headline are not lying by altering the truth, which is the first thing that comes to mind when we say lie. But when you leave it there, you mislead people, because according to the findings of the research team, this stopping and starting to reverse has been happening for hundreds of millions of years, in cycles of about 70 years, throughout the history of our planet. Therefore, the apocalyptic undertone implied by those who share the news without giving any details is complete nonsense. You will understand it much better when I give you the following information. The reason why the first core can reverse is that the inner core has already been rotating independently of the rest of the planet for hundreds of millions of years. Think about what we have learned so far. The outermost crust of the Earth is solid. The mantle is almost liquid. The outer core is liquid. The inner core is solid. If you visualize these layers, you realize that this innermost solid marble can move freely in any direction it wants in the outer core liquid that surrounds it. So it's not surprising that the inner core and any part of it, like the shell, can move in different directions. This has almost nothing to do with the rotation of the Earth on the Earth's crust, what we mean by the rotation of the Earth. Of course, we would expect the interior of a planet to rotate in the same general direction as the exterior. But as we're about to see, this is not necessarily the case, and the dynamics of the interior may be shaped by completely different forces than the crust. But first, we need to understand that this newly published paper is just a new model, in addition to several other existing models. Because it was already realized in the 1990s that the inner core might be rotating at a different speed than the crust. Seismological studies since then have shown that the speed of the inner core can both increase and decrease, but the difficulty of studying the inner core made it difficult to see whether these velocity variations had a certain period or a certain pattern. And the reason for that is very clear. We can't study the inner core directly, because the inner core starts 5,150 kilometers below our feet and has a radius of 1220 kilometers by itself. So the distance between your feet and the inner core right now is roughly the distance between Ankara and Nepal as the crow flies. But as I've told you before, even the deepest hole ever drilled into the earth by humans, the Coke hole, only goes 7 kilometers deep, so you can understand how far we are from being able to directly examine the inner core. But in order to test something scientifically, we don't need to be able to observe it directly or touch it directly. That's what science is for. When there are strong enough vibrations on the Earth's surface, these vibrations propagate across the planet, interacting with much deeper layers of the Earth. As they pass through different layers, the qualities of these waves change depending on the physical properties of those layers, and then they reach the surface again. Some of these strong vibrations I'm talking about are artificial tremors, especially during the atomic bomb tests in the 20th century. But a significant number occur naturally during natural phenomena such as earthquakes. Here, seismographs scattered around the world use supercomputers to analyze how these waves change across our planet so that we can understand what is going on at different depths of the Earth, including the innermost parts. According to these data, the magnetic fields generated by the motion of the liquid outer core, the magnetic fields that protect the Earth from radiation from the sun and deep space and cause events such as aurora, create a gravitational force on the inner core, forcing it to rotate with the outer core. But the gravitational pull of the relatively stable mantle slows down this rotational motion caused by electromagnetism. These two enormous forces compete with each other, causing the inner core to rotate differently from the crust, and this rotation to change direction over time. The newly published model shows that the balance between these two forces causes the inner core to rotate clockwise and counterclockwise in cycles of about 70 years. If this model is correct, the available data show that the last reversal with the inner core occurred in the 1960s. The claim that the Earth's core has reversed, which is the headline in the news, stems from the fact that we are in the 2020s, which is what you get if you add 70 years to the 1960s. So there's no direct data to show that the core stopped and reversed right now or a few days ago. But if the model is correct, the inner core may have stopped spinning and is reversing again. As you can see, while this is a fascinating finding from an earth science point of view, it's not as scary or extraordinary as it's implied to be. Because if the model is correct, the Earth's core would have changed direction almost 1.5 million times in the last 1.5 million times in the last 100 million years alone. The fact that this is happening again is of no great significance or importance. I say continuously, if the model is correct, because since these data are not continuous, that is, they can be collected at regular intervals, it is possible to develop more than one model to explain the same data set. For example, the exact same data collected from the depths of the Earth can also be explained by the fact that the inner core churns during its rotation. That is, it doesn't rotate properly. Similarly, since we don't know the details of the inner core very well, if the surface of this layer is constantly changing, it could also be bending the seismic waves that pass through it, causing the strange results we see on the surface. So we can detect how the scattered waves change during earthquakes or atomic bomb explosions. But we don't know exactly what is changing the wave just by looking at this data. So we come up with different models and theories that explain the same data. All of these models have their shortcomings, like this newly published 70-year cycle model. None of them are perfect, but that's how science is done. If you develop a theory or a model that explains the observations and the facts, in this case the seismograph data collected that theory. If it's a good theory, make some predictions that its competitors can't make. You keep collecting data that allows you to test those predictions. And if your theory can indeed explain more data more accurately than the competitor's theory, then your theory gets ahead in terms of scientific acceptance. Until a better theory is developed that both explains what your theory can explain and also manages to explain what your theory cannot yet explain. Thanks to this method of science, we can reach the truth step by step. And finally, no matter which model is correct, understanding the behavior of the inner core is crucial. Because the motions of the Earth's core could be determining earthquakes on Earth, changes in day length over the years, and even atmospheric phenomena through its effects on magnetism. And this may allow us to uncover some patterns and causality in geological and climatological events that we had not previously recognized. So this is a really important study. As you can see in a nutshell, this research is really exciting in a scientific sense, but it won't lead to the kind of apocalyptic scenario that the media is trying to make, at least not for those whose vision goes beyond Hollywood. See you in the next video. Goodbye.